Okay, now we're gonna look at a couple different looks that you might see here that don't present the same way as those last couple that we went through, right? So for this one here, um, conveniently enough, this is already solved for y, and sometimes you'll get that because they might write it in slope-intercept form, right? So we are going to take this, excuse me, I'm yawning, it's kind of late. We're going to take this and we are going to substitute this in for y into this equation. So it's already solved here. So let's do the purple. Let's just kind of put a box around this. So we're going to take that and then we're going to put that in here for y. Okay, so we're going to go 2x is equal to, and now we're going to write it in purple, 2x minus 7 and then minus 3, right? So I just dropped this in here because they're telling me, well, this is y, and then y is in here. So why don't we just write it as one thing, right? So do some collecting of like terms. So you get 2x minus 10 because you've got negative 7 and a negative 3 here. All right, and then the next step is, generally speaking, you say, okay, we're going to move, the variables over to one side, and there's only one variable here, so let's do that. So when you subtract this one from this side, you subtract it from this side, and then this kind of crazy thing happens. This cancels because you want it to, but so does this. And so you wind up with 0 equals negative 10. And, in most worlds, probably all that I know, 0 is never equal to negative 10, right? So this is clearly a false statement, right? This is false. And so when you get a false statement, this is the algebraic way of saying, hey, we're saying 0 equals negative 10. We know that's not true. So this is saying that there is absolutely no solution to this system of equations, right? So that's what it means when you get something like that. So when you do run across something like that, you can basically stop and go, all right, I'm done. There's no solution to this. Now, the other kind of look you're going to get, right, on this in this other problem here, we got to work a little bit to do. So we're going to solve for one of our two variables. Let's use this one right here because it's a little smaller. So we're going to take this 2y equals 4x plus 1, and we're going to solve for y. So let's divide both sides entirely by 2. So that gets rid of this right here, and you get y is equal to, well, 4 divided by 2 is 2, x, and then plus 1 half. So now we've got this solved for y, right? We've got this, and so we're going to take this and we're going to put it up into this equation right here. So that would be our next step. So we're going to write this equation out, except where we see y, we are going to put in this right here, because that's what we solved for from the other one. So we have 2x plus 1 half, and then it goes equals negative 2. All right, so let's take a crack at this, right? So we've got negative 4 is going to multiply by both of these. Let's just write this out. We've got 8x, and then we have minus 4 times 2x, so that's negative 8x. And then negative 4 times 1 half is negative 2, right? Because 2 goes into 4 twice, right? And this equals negative 2. So in a possibly even stranger thing happens here, right? So 8x and negative 8x, when you combine them, they actually wipe each other out, right? So these go away. And then you wind up with the statement that says negative 2 equals negative 2, which is sort of like the Captain Obvious statement. Well, of course it equals itself. But when you see this in this context, what that means is that this is always true. So the way we interpret that is we say that there is an infinite number, not in fight. Again, getting a little tired. So it is an infinite number of solutions, right? So this is the case we talked about earlier where it's called consistent dependent, right? So the solutions for one depend upon the solutions for the other, but there's an infinite number of them, right? And then this other one over here was inconsistent. So that's kind of where we're at with these. You are going to run across these cases, and it's important to be able to recognize it algebraically when you do see these. So Good luck with these and have fun. Thanks.